Awesome. That is not too bad. Hopefully you see that this is a little bit of a puzzle, and it is the more fun parts of this, and it's what I wanted you guys to have a good feeling for. Just to say how these are named. When you look at the back of a spray bottle, for instance, you'll see these compounds there. Now, the first sort of complication we could talk about is what if they're just a bunch, a straight chain of carbons, and there's one extra thing. Instead of a hydrogen, for instance, we talked about a substituted hydrocarbon. That was right up here. Or hydrocarbon derivative. We're going to go down and we're going to say, what happens if it's just like a chlorine group or a bromine or an iodine, something from the second to the last column. Everything in those columns is intriguing because you may already, as well as drawing this, you're going to notice we're using carbons and nitrogens and oxygens and fluorines. That's the order they occur in the periodic table. But each of these compounds has, for instance, one, because it's got 4 electrons in there. This one's got 3 electrons in it. Oxygen has 2. I shouldn't say it because really there's 2 dots here. I'm going to put those as a line though. Okay, oxygen's got 2 lines. And fluorine actually has 3 sets of lines and only 1 dot. So carbon, when it bonds, it's going to want to use every one of those single ones to loan out to another atom around it. You can always see that carbon's got 4 bonds. Nitrogen, because that top pair is already paired, that only wants to have 3 bonds coming off it. Oxygen, when it makes compounds, is going to want 2 compounds because those other 2 up there are already paired up, and so they can't be shared with something else. And fluorine, bromine, and fluorine, bromine, chlorine are all going to have 1 stick. So these can replace the hydrogens and become this side chain. You're going to name some compounds then today with side chains. The key part of naming side chains is that you want to take a look. For instance, let's go with something like this, which is butane. Okay. Now, if I put 1 chlorine on here, okay, the thing I want to do is I want to give this a number to tell you where that chlorine occurred. And so this is going to become, you number the chains here so that you give the smallest number to the side chain. So it's going to be 2-chloro. Notice this ending here, and then the word butane. Butane says, it's 4 carbons long, and there's a chlorine at the second carbon from one end. So that's how you're going to name these side chains. Let's try a different one. Okay, that's 2-chlorobutane. Let me try something like this. Okay. Now, you're trying to find the longest chain of carbons, and then anything that isn't in that longest chain of carbons. I'm going to leave the hydrogens out so you can just see this. And you can say, what's the longest chain of carbons? 1, 2, 3, 4, or 1, 2, 3, 4, 5. There's 5 carbons there, so this is really a pentane. Notice how I write the base or the parent chain down first. And then you say, well, that's all of these carbons. And here I've taken account for those. What's left over, that 1 carbon? Well, what do you call a 1 carbon chain? Methane, right? But as a side chain, it's going to have the word "il" at the end, so it's going to become a methyl. And what carbon is it on? It's on the 3rd one from either side, so it doesn't matter which end you start counting from. So that's a 3-methylpentane. Okay, so you've got, that's what this 3rd point is how do you number the 2 side chains. And if there's a double bond in it, you want to give priority first to the double bond, number one end to the other from the double bond, giving that the lowest number. And then if there's no double bonds, see if the side chains can get the lowest number. And so let me try one last one as an example. How about something like this? Oh, actually, let's go from the other one. 2-fluoro. 2-pentene. Okay, so what you got is a fluorine at the second carbon, and you've got a double bond starting at the second carbon of pentene. So look at the base chain first and just say, oh, that's pentene, so that's 5 carbons. 1, 2, 3, 4, 5. Give a single bond to every one. After the second carbon here, you're going to go a double bond. Okay, and then on the second carbon, you're going to have a fluorine. So you're going to have, here's hydrogens. You're going to have a fluorine there. These are going to be hydrogens. They've got 4 on every carbon. So 1, 2, 3, 4, that's enough. All the rest of these sticks are hydrogens, and now you can go back in and fill them in like that. Okay, once you've gotten the parent chain and you've gotten any of the side chains in, all the rest of the sticks that fill up the carbons so they all have 4 is going to be that. So give those compounds a try. You should be able to burn through the second page as a good start.